Shall I plug it in?
Good evening again. I think we're going to start now. So thank you very much, everybody, for joining us tonight. This event organized by the Astronomy Groningen. That's the organization that is run by the volunteers for students and researchers at the Astronomical Institute at the University of Groningen. We have a really nice team, so shout out to everybody who is here today or who was not able to join us or are watching us online. Yeah, really great team. Thank you, everybody. Today we have a very it's really my pleasure to introduce our today's speaker, who was also my PhD advisor. So that's a great pleasure to have you today, Floris. So our speaker today is Professor Dr. Floris van der Zak from the Astronomy Institute from the University of Groningen. And Floris will tell us about the CO2 footprint of the Dutch astronomy. So we know that astronomy is really cool and fun, but which price do we pay for this? Please, Floris.
Thank you, Katja. Cheers, everybody. It's a great pleasure to tell you today about the carbon footprint of astronomy research in the Netherlands. So we did this together with this group of people, as you see here, and we represent basically all 6 astronomy institutes in the Netherlands. So I don't think I need to really give a background why we do this, but just in case. Many people already know that to reduce the effect of, or to stop the dangerous effects of climate change, we need to reduce carbon emissions by about half, and we need to do that soon by 2030. For example, read this in the Paris Agreement, or in the IPCC report, or it was highlighted at the Glasgow summit, but you don't really need even to read scientific reports for this. You can just open a newspaper and read about disasters like, wildfires in Australia, floods in Germany. And it's not like each and all of these can be linked to climate change directly, but it's certainly true that the increased occurrence of such disasters, that is clearly linked to global warming. Also, as you say, that the last year's Nobel Prize in Physics went to climate change and modeling. So it's clearly high on the agenda. But now you can ask, so what's astronomy got to do with it? That's a good question. Maybe not so much, but it is also true that as astronomers, maybe a bit more than the average person, aware of the need to respect our planetary boundaries, as they call it. Certainly, many astronomers are well aware that the Earth is, for the foreseeable future, our only habitat, right? Maybe in 100 years from now, we could also live on other planets or so. You read that in science fiction novels, and this maybe one day, okay, but certainly not by 2030. I'm sure you agree with that. So astronomers around the world are getting together and organizing themselves and trying to help society make this transition into a sustainable economy. And then here it helps that astronomers can be pretty well organized. Certainly that's true for the Netherlands, which is not so large, so it's easier to connect to each other. So that's what we did. In particular, so what we have as professional astronomers in the Netherlands is the so-called Astronomy Council. So that's just a body with the directors of all those 6 institutes. So we have 4 university institutes, and we have 2 other astronomy institutes, SRON, for example, and SRON in England. And so they installed this working group 2 years ago, I think it is already. And so seeing what we can do about climate change, just do our part, right? And then the first thing we did was to measure the emissions for 2019. And the reason for that is two. First of all, it's before the pandemic, right? So it's more representative of emissions that are typical emissions. And the other thing is that, as it happens, 2019 is the year where emissions in the Netherlands were the same as in 1990, which is often used as a benchmark to compare emissions against. For example, this 50% goal is relative to 1990 levels. So it's a handy year to use. I could go into a lot of detail about how we did this exactly, but I decided to skip this in the interest of time, because we need to leave before midnight, I was just told. So let's go straight. So let's go straight to how we did this then. And one important aspect of these missions is by travel, and in particular air travel. So we did this. First of all, we collected anonymized flight information, right? Not so much who flew somewhere, but where did they go, right? And we put that in the model by Didier Barrem, and this graph here is from this paper. And you can see all these different curves, and they differ in the so-called multiplication factor. Now, what's that? Well, that's because you can, for example, just ignore this factor and say, well, you know, carbon is carbon, we don't care. That's the position that, for example, the airline industry takes. But that is a little bit simplified, because in fact, what happens, and more realistic, for example, is f=2 multiplication, and that accounts for stopovers, right? So not just from here to New York. Usually people stop over in New York, in London or so, or in any case. And the other thing, perhaps more important, is that CO2 emitted at high altitude lives longer, right? And also creates a bigger greenhouse effect. So that's why this f=2 is probably a realistic number. Some people go beyond that and say, no, you should really use f=3, so even more multiplying. And that will also account for non-CO2 effects, as they're called. So in particular, nitrogen oxides that are also emitted, right? And also reflection on the contrast surface. So maybe f=2 is still conservative, but that's what we use, sort of in the middle of things. So that's the air travel, and there's also other business travel, of course, but that emits very little CO2. So we can safely ignore that. The trains, etc. I mean, there's some emission, but much less. One interesting result that we can learn from this is that actually it's the long flights, the intercontinental flights, that cause most of the emission. That's illustrated by this little graph here. So the top. So these are the flights by Leidenstaaf, just as an example, right? And here's what distance is traveled, right? And you see that most flights by just number of trips, they are within Europe. There's in particular this noticeable peak to Garching. That's otherwise a small town, but in astronomy it's very important because it's a place where it's close to Munich, right? In Germany, southern Germany. It's where many important astronomical institutes are. So people travel there a lot. You can see that nicely here. You can also see that La Palma has this peak here. That's where many telescopes are. Same is true for Chile, for example. US is just, I think, visiting other institutes. So you see that by number of trips, it's really Europe that dominates. But now if you go to the CO2 emission, that's actually much more a broad distribution, right? Not so clearly peaked. Perhaps the peak is somewhere here in the middle. So you can also see the same thing basically here in the cumulative distribution, but I don't want to make this too technical. The bottom line is that, so it's really the intercontinental flights that dominate the emission. Good. So that was about the travel. There's also other sources of emission. There's, for example, the buildings that we use, right? They need heat, they need electricity. So we just asked the housing facility managers for the heating and the electricity bills, and asked them, like, so what kind of power is used, right? Some use green power, others use fossil power. Some use a mix, so we took that into account. And also you need to take into account that in many places, astronomy doesn't have its own building, right? That's shared, for example, with the physics department or so. So you know, you account for that too. Then another source of emission is commuting, right? Traveling from home to work. So that can be taken into account because usually people are reimbursed for that, right? So we just ask the secretaries like, for how many kilometers did you reimburse? Again, we didn't need to know who was that, right? So in that, so if you add that, they're happy to give you those numbers. Right, we assume that this is most. We only took commuting by car or motorcycle into account, assuming that all of that is fossil powered. That is a good assumption, certainly for 2019. The number of electric cars is still pretty small. And then, how much does a car emit again? Well, that depends on how old it is. So we use this number here, 120 grams of CO2 per kilometer, and that is the number from 2012, which sounds long ago. But so compared to 2019, that assumes that a typical car is 7 years old, and that is more or less what this seems to be. And then finally, there's also computing. That's the most uncertain part of the emissions. So it's, we ask the computer support staff, like, so how much of these facilities is being used, and so you get answers. You can in fact break it down into national facilities or national. There's the supercomputing center in Amsterdam. That actually doesn't really count because it's 100% powered by green electricity. And you have a few locals, for example, the Peregrine cluster. That's actually used for her PC cases. I'm sure she remembers. So all that emissions also taken into account. And then if you do all that, you end up with this big table. And let's not go into each of these numbers in detail, right? Because that'll take up till midnight. We don't have that. So let's just look at a few numbers in detail. So first of all, here's the number of staff per institute, and that includes master students, but not bachelor students. The reason being that master students sort of do most of their work at the institute most of the time and doing research. Bachelor students spend most of the time at home or in classrooms studying. Then there's this high number of for air travel from Nijmegen, as you see. That's probably related to that they're very active there in telescope projects, building new telescopes, often in faraway places. The power consumption of SRON is really high if you compare it to the other institutes, and that has to do, so SRON is an institute that builds space hardware, right? Space telescopes, and they do that in so-called clean rooms, which we also work in clean rooms, you could say, but those are exceptionally clean and not completely free of dust in it. So they have expensive machines to keep that going, and they're not only expensive, those machines, but they also use a lot of power. So that's why this is so high. And that's also why it's very good that they, since 2019, moved to a new building which uses green power. So that saves a lot of emissions, as you can tell from this here. Another thing that if you stare at this table long enough that strikes you is this high number for the commuting to SRON. And that's because it's located in this rural area with pretty poor public transport connections. So if you ask the people who work there, is that they tell you, oh, they would love to come by bus or so, but there's just no bus going. So that makes it hard. That's understandable, right? You also see a few zeros. That's great, of course. Right, so some institutes already use 100% green power, and more are doing this. So that's good, of course. You also have these. Some of these buildings are already using this aquifer thermal energy storage. So that's not using any fossil power sources for the heating. That's also very good. And then you have this relatively low number for the flights out of Groningen, and that is suspicious. We suspect that those data are incomplete somehow. So we need to track better who is flying everywhere. Good. So enough for numbers. So let's put it in this little pie chart now. And what you see very clearly, of course, is that air travel is doing about half of the emission for astronomy research, right? And then second is electricity at like 1/3 or so. Heating and cooling, 15%, and commuting and supercomputing are sort of more minor sources of emission. And you can also ask yourself, so how much in total is this emission anyway? And the answer is, well, more or less 5,000 tons of CO2 per year, right? And that, since there are about 1,000 astronomers, that is about 5 tons per research. Is that a lot or not? That depends on what you compare it to, I suppose. But it is a more or less similar number to what other studies have found for certain institutes in France and in Germany. So in that sense, it is comparable. Also, the ranking of what are the dominant sources is similar to those studies. It's a bit different for astronomy in the US. They have also done studies. They commute a lot more and they do it a lot more by car. So that's a more important source of emission in the US. And in Australia, it's also a bit different because almost all of the power in Australia is from coal plants. So that and they also fly more. So those are really different situations, I guess. So air travel is the dominant contribution, and this is only going to go up because what you see is that the electricity is on its way up. So already most institutes use completely green power by now. Groningen, for example, has since 2019 switched to this. So in 2024, actually there won't be any fossil power anymore, and that means that the blue part of the pie is only going to get big, right? Also, these ADAS systems are becoming more common, right? So, for example, Nijmegen recently installed one. So this is also on its way out. So the air travel is becoming more and more the dominant contribution. So I guess you see where I'm getting at. We really need to fly less, right? To reduce this footprint. The good news is that it's not necessary to completely stop flying at all, right? But we need to fly less by, well, between 2 and 4 times less. So let's say 3 times less than we did in 2009. So that is significant, of course, but it is not as drastic as a complete ban or so. Well, it does mean that some prioritization is needed. So let's see in the last part of this talk a little bit about possible ways to reduce this footprint. And since travel is the most important source, let's begin by trying to reduce that. So within Europe, clearly what would make sense is to take the train whenever this is possible. It helps that more and more institutes now are reimbursing train travel, even when it is more expensive than flights. You have these very cheap flights, right, for these local carriers. And so that's hard to compete with if you only look at the money. But more and more institutes are now considering, well, you know, we also reimburse you the train, even though it costs more money. So that's good, but that's not enough because remember that it was the long haul flights that caused the most emission, and you cannot really travel to the United States by train. I guess you could do it by boat. It takes kind of long. So what needs to happen also is to embrace online meetings. The days of physical meetings, they are not completely over, I guess, but we really need to embrace this online meeting concept. And an interesting example is the annual meeting of the European Astronomical Society. That was organized in the last 2 years as an online meeting, right? Because of the pandemic. And some people calculated that this reduced the carbon emission due to that meeting by a factor of 3,000. Yeah, so that's pretty good. Not to zero, of course, because computers also use power, etc. So it's not zero, but of course it's a fantastic reduction. And online meetings have other advantages too, right? They not only reduce emission, but it also saves travel time. It saves travel money, and in a way they're also more democratic, right? Because everybody is on the same screen, and then with less dominant people nodding. I guess you know what I mean. They're also online meetings are in a way more inclusive towards, for example, disabled people people with limited travel budget, people with small children at home or other people to take care of, people with busy teaching schedules, so much easier for many astronomers to attend online meetings than it would be to travel to some remote place. That doesn't mean, I'm not trying to say though that online meetings are perfect and the solution to everything. It is nice to sometimes be in a bar, for example, and discuss things. So what clearly needs to improve more for online meetings is the social aspect of meetings. So one shouldn't like only have a series of streamed talks, but you also need some kind of chatting platform around it, or you should be able to with another attendant, let's have a bit of discussion together now about this. So an interesting development here are also these virtual reality glasses are becoming less and less expensive. And so you can, I've heard people, I haven't tried this myself, but apparently it's now possible to, be in the same VR room, so you can simulate pretty well these days online that you're meeting in the same place. Choose it, you can choose it to be an exotic island or stuff without actually using it. So that's certainly on its way, and that makes it much better possible to do. And for these online meetings, they are very efficient, but they can also be fun as well. Still, that's not. I'm not trying to say that we should only meet online, right? There will still be a need for meeting physically now and then. And then it would, of course, be much better to meet in central places which are easy to get to. So, not at these remote exotic islands, that's nice, maybe, but this is, of course, a big source of CO2 emission. So, one idea would be this model by the Seafood Consortium, that has to do with an X-ray telescope, but that's not so important now. So, what they do is they have 2 meetings per year, okay? And what they do is one meeting they do physical and the other they do online. So, that reduces their carbon footprint by a factor 2. Right, so that clearly helps a lot. And you do have to accept, perhaps, that online meeting is a little bit less efficient. So you may need more meetings or to achieve the same goal. But then you can do that if you do them online. Another idea that is sort of coming back from the past is this notion of responsible travel. Right, if you do travel to the US, don't go there for just one day to give one talk, but spend, go there for a few purposes, like visit a few different institutes and give the same talk a few times, or go there and talk to colleagues about something, combine it with an observing trip, something. A question that I often get when I'm presenting these results is, what about CO2 compensation schemes? You may have heard that people companies offer these schemes that you fly somewhere, but we offset your emission by planting trees somewhere, and that's not by itself not a bad thing to do, I suppose, but it is not possible. There's just not enough land to compensate all those CO2 emissions that we are producing. So that it's not a bad thing to do, but it's not enough. It's not a long-term solution. Yeah. Okay, so here's a practical scheme where this is from the University of Groningen website. Okay, can you read it? You can see what it means, right? So this is to illustrate this idea of using the train instead of the airplane within Europe. And so what's marked here in green is where I think you travel less than 6 hours by train, so they consider that as more or less easily doable. They have a few yellow destinations like London, Strasbourg, and Lyon, which are sort of far, but they can still acceptably done by train. And then even further away, more than 8 hours, I believe, is the limit, is where you can take the airplane. And so this example is from Groningen. I think Amsterdam and other universities are adopting similar policies. So that's going to help. But as I mentioned, so it's not enough to completely outwash the carbon footprint. So that's so much about the travel. There's also the non-travel, for example, the commuting. Clearly, public transport is preferred here. Also, if you can use the bike. These days, electric bikes get you pretty far. Working from home, of course, pandemic style is a great way to reduce emissions. If you must use a car, try to not to drive it alone. And I guess more further in the future, electric cars and so on will become further into the future. Electric airplanes, but that is not for not something sudden. It's still too expensive, but it will come. And then, yeah, for computing, it will be good if you will use specifically facilities that are not powered by coal. And let's now come back to this, if possible, because that's kind of a tricky thing. Right? Do you take the train to Paris? Well, probably most people would do that. But do you take it further to Strasbourg or so, or to London? It's kind of far. The airplane is quicker, right? And this is kind of tricky. And the same is true for public transport. You know, if it is remote, right? And do you do that? Well, what is acceptable? How much extra time is still okay? That is sort of a personal choice, and that is differs from person to person, and that wouldn't be so fair. So here is where I think is a role for organization, for politicians, like I say. So what we need are guidelines, because if you just leave it up to everybody by themselves, that wouldn't really be fair. Some people would take the train much easier than others, so to say. So what we get if we have guidelines, for example, in form of a carbon budget per institute. That's what we recommended to the Astronomy Council. Yeah, and then how they do that on the ground, that's they can decide it for themselves. But so just to be mindful as an institute, like we have only so much carbon to emit, and we need to spend that wisely, so to speak. Another question I often get is that, well, you really, with this study is limited to the Netherlands, but shouldn't we organize this, you know, for all of Europe or even the whole world? And I guess, yes, that would be nice to do, but that'll take a long time before we get that organized. And so you can see this problem also very well at these climate summits, right, in Glasgow and Paris and all those others. It's difficult to reach consensus because different countries come from, you know, a different background and they have different attitudes towards this. So that's not easy to organize. So, but it would already be very good if we could get this organized from them. Then having guidelines is good. This then needs to be worked out further for each institute, and in particular, in a way, in a fair way, in a way that nobody is left behind, right? So we need to have good guidelines, which, you know, take into account that different people have different needs, and this needs to be balanced. And so that would be a role for the staff of every local institute. What also would help, I think, is if funding agencies required a sort of a green policy, sort of a compliance with the Paris Agreement standards to fund projects. And also, so we did this study now for 2019, but what we really need is also, you know, repeats perhaps every year. And so this first time took a long time, and there was a lot of effort to dig out all those data. It would be really good if next time it would be easier, if we could sort of automate this data flow and then do this, so that would be very helpful if the secretaries could play a role there. And then there are things that they can do with new buildings, right? So here's this new SRON building in Leiden with solar panels on the roof, and it uses this smart lighting also things. So if there's nobody around in the building, the lights go off. Makes sense, right? Also, I mentioned these cities. Non-fossil heating systems. And last but not least, I think it would be good if employers, you know, have these financial incentives to also do the commuting in green ways. That's what I have to tell you today. I want to finish by thanking all these people who were very helpful in getting all this data together and with the analysis. And I wish you good luck with the pups.
Thank you very much, Floris, for a very nice talk. And I would say I was relieved to hear that we can keep doing astronomy, it's not so bad. I wanted to ask a question though. So when you showed the table where you calculated all the CO2 footprint, depending on different activity, different institute that they do, I noticed that actually the carbon emission from the clean rooms at the SRON, so Space Research Organization of the Netherlands, I think it was the highest number from the entire table. So I was wondering then, if we try to do the same calculations for the chemistry department or for physics department that have much more clean rooms, does it mean that like we have to stop doing physics and chemistry?
Yes. Well, but on the other hand, if you can power those clean rooms with, wind or solar power, then you can run them just fine. You're not creating any emission, right? So that in a way is a simpler solution than reducing all those flights. Yeah. So I think there is a future also for physics and chemistry.
I'm curious how our flights compares to, for example, chemistry or physics. I imagine astronomy would fly more to these telescopes than other fields of science.
Yeah, I think that's true. Although most sciences have conferences, international meetings, and that's I guess similar for astronomy and chemistry alike. But yeah, travel to telescopes is something particular to astronomy. I think that is already much less so than it used to be. More and more telescopes these days are either robotic or operated by staff at the telescope. You just tell them what to do, or you send them a script, and you later download your data from some repository. So travel to telescopes is already much less than it used to be. But I haven't done the exact comparison, like how it compares quantitatively.
Do you have data on how much better / worse we're doing compared to other fields of science?
So yeah, that's a similar question to what was just asked about chemistry. So I think in terms of flying, probably astronomy is a bit worse, but it could be that these laboratory facilities, and I don't have data on that. That's a short answer to the question. But that would be interesting to find out. On the other hand, what would that mean? I'm sure you can find other activities in astronomy which are more polluting than but that doesn't mean, of course, that okay, we can sit back and we don't have to do anything. We we should do our share regardless of what the others do.
Or we should purge that field. Just kill it.
As academics, I guess that was the chemistry. If it's not water, it's not H or HE, so no. So that was the equals of our working lives. But how does that compare to sort of living? So does that make a difference if you're like a meat eater versus being like a vegetarian?
I didn't really hear that. Sorry.
So that was the ecological cost of our working lives as academics. And how does that compare to us to just living? So is the difference between us going to a conference or two sort of comparable to being vegetarian or a meat eater, or how expensive is that compared to our other lives?
I don't think I have data on that. What is known from other studies is that there tends to be this trend with income, that people who earn more tend to also emit more CO2. Perhaps not so surprising. So this is true for if you compare country to country, but also within country if you compare different classes. I think there are, what you're asking about lifestyle, I think that's of course an effect. I'm not sure if I have really data to answer that, but it's interesting.
a question. So if you cannot get rid of intercontinental flights, how else can you power airplanes that would be more green?
I don't think this is possible by 2030, but people are trying seriously to build electric power planes. They exist for small number of passengers and for short distances, and this is certainly field in development. But for now, because we don't have the time to wait for that, okay? We need to reduce now and then be on the 50% mark by 2030. So in order to do that, we just need to fly less. Yeah, but in long term, we can think about alternative ways of transportation, and electric airplanes hopefully will come with it.
I have another question. So in one of the suggestions, you said that one of the ways how to reduce also the carbon footprint is to work from home, so the Corona style. But at the same time, you were showing us that all the institutes, they are moving, like some already are at the point where they are located at the zero, like CO2 zero emission buildings. And this is really not the case, I think, for the houses that we live in. So, for example, I think going to work at the office will be much more cheaper carbon footprint wise than me staying at home and heating the house only for me and my cat. So, also that's what I was wondering, with the shift towards working at home, during the Corona and now post-COVID, I think there will be more people willing to work from home. Yeah, would this again increase our CO2 footprint?
Yeah, that's a great question. That depends. So I was meaning this work from home specifically to reduce emission due to commuting, right? But of course, if you live within walking or bicycling distance from your institute, then indeed it is probably better to not work from home. If the office uses green power and so on, that's a good point. So to work from home, or move to to the vicinity of your work, that would also help.
Or use your cats for heating yourself.
Every astronomer needs to get a cat.
Don't feel very sorry for catching a cat. You get to stare at no unless it can generate it itself.
Just around.
Yeah, I don't think we should tell our cats that we're really using them as our heaters.
They're only using us to open doors, so it's a two-way relationship.
More questions?
Yes. So if there are no more questions, then we will have now a small break, and then we'll start again with the pub quiz. I would love to say thank you very much to Floris and give him our brand beer glass as a present. Thank you very much for the talk. All people who will ask the questions, you can come to us during the break. We have really nice Astronomy on Tap stickers, so we'll be very happy to share them as well. Yeah, and see you in 5-10 minutes for the pub.
10 minutes, buy more beer.
Yeah. Get drinks, tea, beer, wine, anything you prefer. Also some water.
Start it as a team.
Is it tea?
Yeah.